Okay, let's look at all the rules in the same place. So first of all, we have all of our triangles all at the top from elementary school. We have scalene, all sides, all angles different. We have isosceles, two sides, two angles are the same. We have equilateral, all sides and all angles are the same and all 60 therefore. A right angle triangle where we have a 90 degree and we can use Pythag. And we have a squared plus b squared equals c squared. We have congruent triangles, which are equal triangles of SSS, SAS, ASA, and AAS, but remember, and then HL, excuse me. And then that funny case, the AS case, which is just maybe, but maybe not, so asterisk, as we saw in the notes, or similar triangles. Remember, go through the notes before the review sheet. We talked about supplementary angles, angles that add to 180. We talked about complementary angles, angles that add to 90. And then angles on a point that add to 360 off to the right, identifying your parallel lines with two ticks. If we have opposite angles, the X rule, they're equal. If we have a Z and we have parallel lines, the alternate interior angles are equal. The angles across the transversal interior inside of the parallel lines. We have corresponding angles and corresponding angles are equal. We have off to the right co-interior angles, angles that add to 180. Then we just have a little summary of all of this. Off to the right, we have our polygon rule about dividing the polygon into triangles. Further off to the right, we have the semicircle rule. Angles inscribed in a semicircle are 90 degrees. Let's go bottom left. So remember how to identify the arc and shade the arc. We have two formulas that you might use. Theta is to 360 as the area is to pi r squared, or theta is to 360 as to arc is to 2 pi r, the circumference, obviously. Little to the right, we have inscribed angles from the same arc are equal, and the central angles are twice that, or vice versa. We have the tangent rules. I'm going to scroll up a bit because the video is going to get in the way. We have the tangent to exterior point rule where we can tick the equal lines. Then in the same diagram we have a chord with a radius and we know that it meets it at 90 and cuts it in half. Up to the left, variation of that rule. If the chords have equal lengths, well, then it cuts the other two chords in half and all those little sections are equal. Interior angles, opposite interior angles of a cyclic quadrilateral add to 180, therefore they all add to 360. And then this funny rule, an angle in between a chord and a tangent is equal to the angle opposite of that chord. So remember, go through the chapters, watch all the individual sections one by one, try the practice, print off the review sheet, make your own.